All right, so in this video, we're going to be looking at, is one form of the AP exam harder? So it says last year, East Kentwood High School had 30 students take the AP Stats exam. They were informed later that the College Board gave two forms of the exam, which were randomly assigned to the students. Here are the results. So they gave us a list of the scores for Form A and B, and it asks us to find the mean score for A, mean score of B, and then the difference. So if you were to average all of these numbers, you're going to find that Form A's average was 4.20, Form B's average was 4.00, so a difference of 0.20 or 0.2. Now it says, assume the two forms are the same difficulty. So if Doug, for example, scored a 5 on Form A, he would also score a 5 on Form B. In other words, Doug is a 5 no matter which form he randomly assigned. Now the 30 AP scores from the class are written on 30 cards. Randomly assign half the students to get Form A and the other half to get Form B. What is the difference in mean scores for this random assignment? So in other words, we're trying to simulate the random assignment that students got for these forms, right? So then when they walk in to take this AP exam, it doesn't matter who they are. They're going to be randomly given Form A or Form B. So we're trying to randomly simulate that or randomly recreate that using note cards, right? So if you were to do that, let's say, for example, you got a difference of 4.27 average score for A, and then for B, you got 3.93 for a difference of 0.34, okay? Now, if every student did this, like let's say, for example, we had a classroom of 30 students, right? So every student did this and got a difference, okay? So let's just pretend we did that. And so each one of these dots I'm about to put down represents a difference that each person got in this classroom, okay? So let's say I got one right there. I got two at negative 0.6. I got one at negative 0.35. I got let me count here. 1, 2, 3, 4, 5, 6 at negative 0.2. I've got 10 at negative 0.1. I've got 3 at 0.05. I've got 2 at 0.2. I've got 4 at 0.35. And I've got 1 at 0.6. So each one of these dots represents a simulated sample of Form A minus Form B. It's looking at the difference in scores, right? And now, so this is the randomization distribution of X bar sub A minus X bar sub B. All right. Now it says East Kentwood had a difference of mean scores of 0.2. Is this outcome surprising if we assume both forms are the same difficulty and explain? In other words, it's asking us, what are the odds that the true mean difference, so mu sub A minus mu sub B, is not equal to 0, right? Okay, so if I'm looking at this is, in other words, it's a two-sided test, okay? So they had 0.2, so what are the odds that we have a difference of 0.2 or negative 0.2 or more? Okay, so if we count up all of these dots, we're going to have a p-value of, count up all of these dots, count up all of these dots. You're going to find a p-value of 17 out of 30 total, which is the same thing as 0.57. Okay, so is it surprising? Okay, no, that would not be surprising. 57% chance. So assuming the two forms have the same difficulty, there is a 17 out of 30 or 0.57 probability of getting a difference of sample means of 0.2 or greater by random chance. And then number 4 says, based on the simulation, do we have convincing evidence that one form of the exam is harder, and explain? Now, p-value of 0.57, that doesn't really bode well for the alternative, right? That means it's very common for that to happen. So no, all right, since 0.57 is greater than 0.05, we fail to reject the null. And then we can say we do not have convincing evidence that one form of the exam is harder. Okay. So, important ideas from this. Number 12 bullet point is your hypotheses. Okay, so same type of hypotheses we've been doing for your null. Okay, since we're looking at a difference, it would be mu sub 1 minus mu sub 2 is equal to 0. Okay, it typically means that there's no difference. In other words, mu sub 1 equals mu sub 2. Okay, that's typically what it's saying. For your alternative, you're usually saying there is a difference. So you might say something like mu sub 1 minus mu sub 2. You would either say greater than 0, less than 0, not equal to 0. Okay? It's one of those things. So you're going to choose one. All right? Now, something else you need to do. You need to define mu sub 1 minus mu sub 2 with direction. Okay? All right. And then the other thing, number 13, as always, your conditions. Okay, so just like normal, you got to do random. You need to do 10% rule. And you need to do normal. Okay, for both groups. All right, I'm going to leave the check your understanding for you. Okay. And then the next thing, it says, does labeling menus reduce calories? So according to Stanford Business article, Americans may eat fewer calories at restaurants if the calories of the food items are labeled on the menu. To investigate this, researchers compared Starbucks receipts from locations where the menus were labeled to receipts from stores where the menus were not labeled. A random sample of 30 receipts from stores with menus labeled had an average number of calories of 225 calories with a standard deviation of 100 calories. A random sample of 40 receipts from the store without menus labeled showed an average of 265 calories per receipt with a standard deviation of 75 calories. Does this provide convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than at a Starbucks without labeled menus? So we're going to do a 4-step process. In the state section, you got to show me your parameter. So mu1 minus mu2. What does that represent? So in the case of this one, this represents the true difference in mean calories per receipt. True difference in mean calories per receipt. A Starbucks for labeled and non-labeled menus. And in parentheses, I'm going to put labeled minus non-labeled. Okay, so showing direction. For my hypotheses, my null, I'm going to assume that there is no difference between them. So mu1 minus mu2 gives me 0. For the alternative, I'm going to assume that the number of calories consumed is going to be less for those with labeled menus, right? So I'm going to say mu sub 1 minus mu sub 2 is less than 0. Okay. Now my statistic, it told me mean 1 and mean 2. So the mean calories at location 1 was 225 minus 265 for location 2. So I'm going to get negative 40 as my statistic. And my significance level in this case is 0.05. All right, now, name of the procedure, I have 2 samples, so it's going to be 2 sample t-test for mu sub 1 minus mu sub 2. Now, conditions. Okay, so random. All right, so it told us these were independent. Well, it told us that they were random samples of 30 and 40, and they have to be independent because you can't be a location that does and does not have calories listed. So you can't have stores that are in both locations. So these are independent random samples. And parentheses below it, I'm going to put, or quotations below it, it's a random sample of 30 and also random sample of 40. Okay, so random is good. Next one, 10% rule. There's thousands of Starbucks across the world. So it's safe to assume that 30 is less than 10% of all receipts from labeled locations. And 40 is less than 10% of all receipts from non-labeled. Just going to put NL for short. Okay, so that condition is good for both. and then normal. Both of these are larger than 30, so we're going to be good at that. So greater than or equal to. So 30 is greater than or equal to 30, and so is 40. So central limit theorem works for both of those. All right, so conditions have been met, so now I can go down to the do section. So our mean, okay, we're assuming that mu sub 1 minus mu sub 2, we're assuming there is no difference between the two. Now, the general formula, okay, since I'm doing a difference of means, is going to be x bar 1 minus x bar 2, that's our statistic, minus mu sub 1 minus mu sub 2, that's our parameter, divided by our standard deviation. So that is square root of S1 squared over N1 plus S2 squared over N2. Okay? And I actually need to write this down here. So this is our specific formula. So again, test statistic for the general formula. Test statistic is equal to statistic minus parameter divided by our standard deviation. Okay, so if I plug in all my numbers, I'm going to get, we had a difference of negative 40, right, minus our expected value of 0, divided by our square root, which is in this case, if I calculated the standard deviation here, okay, they told us that the standard deviation for group 1 was 100, and then group 2 was 75. So I'm going to have the square root of 100 squared over 30 plus 75 squared over 40. So if I plug all of this in, I'm going to get a standard deviation, or excuse me, a test statistic of negative 1.84. So if I draw a picture of this, I've got my distribution. In the middle, I'm going to write a standardized graph. So in the middle, I'm going to have 0. And then right here, I'm going to have negative 1.84. Then I'm shading in this area. And then don't forget my name, T. And then we had the smaller of the two samples was 30, right? So my degrees of freedom here are going to be 29. Okay, always go with the smaller of the two. Remember, my test statistic was negative 1.84. So my p-value, if I do TCDF, I'm going to have a lower bound of negative 9999. I'm going to have an upper of negative 1.84. And then my degrees of freedom of 29. So if I do that, I'm going to have a p-value of 0.038. So if I'm writing a conclusion here, okay, 5% significance level. So first off, I need to interpret. So assuming the null is true, in other words, mu sub 1 minus mu sub 2 equals 0. I'm going to say there is a 0.038 probability of getting x bar 1 minus x bar 2 of negative 40 or less by random chance. Okay, and now our significance level is 0.05. So since our p-value is small, okay, in parentheses, I'm going to put p-value equals 0.038, which is less than our significance level of 0.05. I'm going to say we reject the null, and then we can say we do have convincing evidence that the average calories per receipt is less at locations that list calories. Okay. All right. So, important ideas from this, okay, would be the 4-step process. So, if you were writing a 4-step process for the difference in means, this is bullet point number 14, by the way. All right. So, in the state section, you need to show me the biggest thing is mu sub 1 minus mu sub 2. All right? This is the true difference in means. All right? You need to list the order. Make sure that you list the order. Okay, tell me, are you doing labeled menus minus non-labeled? Are you doing non-labeled minus labeled? You need to give me a direction that you're doing it with. In the plan section, okay, so the name is a 2-sample t-test for mu sub 1 minus mu sub 2. All right. And you also need to check your conditions as well. Don't forget that. You just need to make sure that you do it for both groups. All right. In the do section, some important things. Number 1 is our test statistic, T. That's represented as x bar 1 minus x bar 2 minus mu sub 1 minus mu sub 2 divided by our standard deviation, which is the square root of S1 squared over N1 plus S2 squared over N2. And then also don't forget to draw your picture. Okay, so if you have a graph, don't forget, like, let's say, for example, you're measuring at and below. It would look something like this. But then you've got T and then whatever your degrees of freedom are. And then in the conclusion, so in the conclude, don't forget you need to interpret p-value. And draw your conclusion. So do you reject or fail to reject the null? Do you have or not have convincing evidence of the alternative? All right, so check your understanding. Going to leave that for you. Last thing we're going to talk about, it says, does memory training help? Part 2. Suppose that 32 seniors were randomly selected to try both memory strategies. Each student calculated the difference in the number of words, strategy 1 minus strategy 2. The mean in the differences was x bar diff equaling 1.5. Standard deviation was s diff equaling 2.7. Do these data give convincing evidence that strategy 2 improves memory at the 5% significance level. So let's say I'm trying to construct a hypothesis test for this data. So in my state section, I need to identify my parameter. So in this case, it's mu sub diff, okay? So mu sub diff represents the true mean difference in words. So true mean difference in words. Okay, in parentheses, I'm going to put strategy 2 minus strategy 1 because that's how they got those values, right? Give direction. So, hypotheses, we're going to assume that the mean difference is 0, right? There's no difference between the two groups. But in reality, the alternative, we might be thinking that mu sub diff is greater than 0, okay? Strategy 2, meaning strategy 2 is actually better than strategy 1. All right, so our statistic, x bar sub diff, that equals 1.5. And our significance level is 0.05. All right, so for the plan section, name of the procedure, we have one mean here, so it's going to be one sample. T-test for mu diff. All right, and then for the conditions, so random. So it told us 32 seniors were randomly selected. Okay, so we're good there. Next up, you got 10% rule. All right, so it's safe to assume that 32 is less than 10% of all seniors. Safe to assume that there's more than 320 seniors, right? And then last one is your normal. This one's easy because we got a sample size of 32, and that's greater than or equal to 30. So our central limit theorem is done. That checks out. All right, so conditions are met. Next thing, in the do section, we got a general formula. So remember, test statistic is equal to your statistic minus your parameter divided by your standard deviation. So specifically for this formula, we got T is equal to x bar diff minus mu sub diff divided by standard deviation. So that's S diff over root n. All right. So if I plug all of this in, I'm going to get 1.5 minus our expected value of 0 divided by, we're going to have 2.7 divided by square root of 32. So if I calculate that, I'm going to get a T value of 3.14. So if I were to draw a picture of that, I'm going to get something like, here's 0, here's 3.14. So I'm counting everything at and above that. So I'm going to get, also don't forget my name, for the graph T and then my degrees of freedom. Well, I had 32 in the sample, so my degrees of freedom is 31. All right. Remember, test statistic T equals 3.14. So if I do my p-value, TCDF of 3.14 up to positive 9999, degrees of freedom of 31. So this is my lower, my upper, and my DF. I'm going to get a p-value of 0.001. All right, so that's a fairly small p-value, right? So two things I need in my conclusion. First off, interpret the p-value. So I'm going to say, assuming the null is true, in other words, mu sub diff equals 0, there is a 0.001 probability of getting a mu sub diff equaling 1.5 or more by random chance. Now, 0.001 is small, so I'm going to say since my p-value is small, so in parentheses I'm going to put p-value equals 0.001, which is less than our significance level of 0.05. I'm going to say we reject our null. And then I can say we do have convincing evidence that strategy 2 improves memory. All right, so we have convincing evidence to show that strategy 2 is the better of the two learning strategies. All right, so important ideas, okay? So number 15, bullet point. All right, so it's the significance test for a mu sub diff. All right, so the name of it, just remember it is one sample t-test for mu sub diff. The test statistic itself, t is equal to x bar diff minus mu sub diff divided by your standard deviation. So it's S diff over root n. And then if you're doing the last one, number 16, so paired t versus two sample t. So you might be wondering, well, some of these we've had two samples and it's been just two sample t, but sometimes we have two samples, but they're grouped together, so it's just one sample. So how do I know the difference? All right, so paired t versus two sample t. All right, so for paired t, typically there's one sample. Okay. In other words, the data are paired. So like in the case with the strategy, you're trying to figure out which strategy works better, strategy 1 or strategy 2. That is paired data because you have a pair of data for every one student. Each student did the strategy twice, strategy 1, strategy 2. So those two pieces of information are tied to one person, all right? So you might have two pieces of information, but because they are tied to one person, it is paired data, all right? So you have one sample, okay? Something else is you have, it's the mean of the differences. Okay? In other words, it's mu sub diff. Okay? And then something else, you typically subtract, then average. Okay? So you subtract and then average. For two sample, okay, for two sample, there are two independent samples or groups. Two independent samples or groups. So like in the cookies example, so we looked at the number of chocolate chip cookies in Chips Ahoy cookies versus Major Chipsters cookies, right? Those are two independent groups. You can't have both of those together. Same with the calories on the receipts for Starbucks. Those are independent groups. You can't have a receipt that is both from Starbucks that list calories and Starbucks that don't list calories. They're independent groups. All right. Something else. It's typically a difference of means. Okay. One is a mean of differences. The other is a difference of means. So in this one, you would be doing, say, mu sub 1 minus mu sub 2. All right. And then the last thing, you typically average, then subtract. Okay, so you find the average of group 1 and then subtract group 2. Okay. In the first one, in paired data, you usually subtract and then find the average of those, okay? So it's a different order of how you do it. All right, so I'm going to leave the check your understanding for you. Again, the key is on Canvas. It's also in this packet here on the QR code. Go through that, and then you can check your work with the key there.